types of motors in the field. We don't have to really per se know each type. You can always read the label or go and look it up. This is resistance start, induction, run motors. As you can tell, they usually tell you how the motor is run, what kind of phase is it, but they always come up with new types. So this kind of motor has a start and running winding, which kind of similar to the split phase, but it has different winding. It's not a phase, it's a separate winding, entwined with the other winding. Phases are split by makeup of this type of winding. Troubleshooting, we did the troubleshooting already. So basically go look at the switches, look at the winding, and make sure nothing is frail, coming apart, nothing is touching the casing. Capacitor start, induction run motor, those only have a capacitor. They do not have, a start capacitor, not a run capacitor. What does a capacitor do? Chris was asking me that the other day, what is the function of a capacitor? So if you ever heard of the term rectification, rectification is changing AC to DC, or kind of getting something out of the AC current. So just to make things simple, if you look at AC current here, we have something called a diode. A diode is like a check valve that only allows the current to go into one direction. A diode is always also coupled with a capacitor. The capacitor gets charged, and by doing so, it will eliminate one of the peaks, and the diode will only allow the current to go into one direction. So the capacitor gets charged while we go into the peak, and just dispense the charge as we go to the peak. So what we end up having is just a series of peaks.
Oh, so it just changes it to DC?
AC to DC, direct current with some kind of known quantity. So it does change AC to DC. It does also change the value, change also the wave. It's also using something called filters if you're sending waves. So that's why we use a lot of capacitors. That's why when you also look at small boards, they do have capacitor for the same kind of purpose. If you look at this complicated board here, this is a small capacitor inside a small circuit, just to alter the direction of the current. If you go into electronic, probably you will understand a lot about that. They talk about the waves and how they actually shape and form those circuit currents. But let's not get too much into it. All you need to know is there's a capacitor for running, a capacitor for startup. That's all.
You said there's only one for this stuff?
Yeah.
There's only
So
one.
when the capacitor starts, only to start it up, and that's it. And depending again on the length of how long the motor runs, what is the torque required, what is the operation, you can try to change how it's made. And again, the purpose is you want the motor to run smoothly, meaning it consumes less energy, and you want to make the most out of this winding. And I also give you the example of small little motors and torque cars, how they get smaller now and have more torque. Basically, in knowing how to make the magnet inside the motor stronger and how to make the most out of this electromagnetic force. So this already capacitor is put in series with the start winding. If you want to troubleshoot that, you usually look at the winding, bearing, and capacitor. It's always the same things that we are doing, which we did in the lab. So look at the capacitor. How do you know how to test the capacitor by now? Discharge the capacitor before you look at it. You want to exact. Look at the winding. We did that. Look at the bearing. Move it by hand. Make sure it's smooth. And as you've seen from the lab, that is not really rocket science. Just be careful and don't break any wires. If you break, you can solder them back. A lot of those wires are spot welded. They are soldered, so they will stay in place. And when you put it back, try not to crimp any wires. But they are designed to run and be taken apart easily. If something is sealed or welded, do not try to break it. Probably there's a reason for that. Leave it as is. Capacitor start and capacitor run. Usually for motors that requires a lot of torque. They produce high starting torque, and they have, so the high starting torque is because of the startup capacitor. Smoother run is because of the running capacitor. The smoother run is due to the alteration of the magnet inside the motor. So again, if we look at the at the wire going up and down, if we have a capacitor, maybe we can direct the magnet or the current in a certain direction. It begins with the phase displacement between starting and running winding. So we have a start winding and running winding. We do phase displacement, which basically we branch a phase from the actual current. Troubleshooting, if you look at one of those motors, they have a lot of wiring and they have a small board that actually control all the operation. So all you can do the same basic three things. I'm gonna write them down, what to check. Bearing. How do you check bearing? Smooth movement. Smooth movement. Actually, probably bigger for everybody.
So a smooth movement if you heard like some
Scratching.
scratching.
Yeah,
something
resistance.
Something rattling.
Yeah. Noise. What else? Rust. So this is the first thing we do, try to move it by hand, make sure it moves smoothly. Some of them are hard to move, but it's not due to friction. It's because there is some kind of magnetism inside. So you move it and you can see it stop by itself, has some kind of brakes. It's how it's magnetized. So we'll check the bearing, check the winding. For what? Color? Loose. How is it loose? Loose wires. Obstruction.
What did that second say? What wires?
Loose.
Wires?
This is how it's put loose?
No, there's an E after S.
Yeah, I was like,
There you go.
Oh, what's after smooth on the bearing?
Smooth movement.
Oh.
So bearing, wiring, that's the winding. So what else? And you can also check for the resistance. Actually, check amperage drop. So that seems very simple. Three-phase motors are available usually for industrial applications and also for commercial buildings. We have large, heavy compressors. They're very rugged, reliable, and they are very dependable. There is no startup apparatus, no capacitor. They have high winding, and because we have three different kind of poles, it will never get stuck. It will always going to be moving. Same principle, single phase, just you have more phases going intertwined. So the only thing you can do, I don't think it's really easy to open it up. It's very huge and heavy. When we did that in the large mechanical shop, we used to use a crane to move the stuff. Again, you want to be very careful. If you drop, who had a last class? Somebody had a motor with a bent shaft. How did we bend the shaft? Probably it was dropped. If you drop the shaft, you will change its geometry a little bit. So it might rattle. With large equipment, usually there's kind of an eye where you can use overhead crane and move things. Because it's really heavy, and there's a big possibility that you will drop it. And it's not even that. If you don't put it, if you try to crimp it with a small angle, you might have it crimp and vibrate. So they're really huge. Electronically complicated motors, they're very expensive, but again, they have so many functions. You can change the speed, you can change the polarity, you can reverse, and they are brushless DC. They work with DC current, not AC, but they are also brushless. There are no brushes to reverse the rotation. They can be also three-phase motors. There's two parts. There's a motor and a control. Usually there's a big box of control outside of it, and it has a program in it. So they're really hard for us to diagnose. Usually they are sent out to the manufacturer to fix. But you can again check the visible things in our side. You know, you can look at the bearing, you can look at the wiring, and see what's happening. They have various interfaces, strategies of models, so it can be again slow or fast, different torque, different rotation. Where would you find those? Sometimes, either in mini splits or in ACs coupled with furnaces. Why? Because you will have high speed fan, low speed fan, and it will modulate more. So if you go to a furnace coupled with an AC, probably you will see ACM, electronic commuted motors. Pneumatic compressor motors, do we know what it looks like? It's over there, in the back, that black cylinder. It is sealed. We do not open those. They come with single phase and three phase shell with the refrigerant and oil. You can do the maintenance stuff, which is check the refrigerant from the outside. You can check the capacitor. You can check the oil, but it should not be open. They do get repaired, but again, they get sent out in a specialized shop to be cut open, repaired, then sealed again. And sometimes not even worth the cost. They get a lot of this equipment. They get sent to the Far East to be fixed in some shops, and sometimes they just go for recycling. No. So you want to identify the terminals. What would you find at the outside? The start up capacitor, start up relay, start up resistance. There's always some kind of way from the outside of the compressor to enable the startup winding and cut off the startup winding. Troubleshooting, you only deal with the outside, you don't deal with anything from the inside, and you just want to make sure that this is the problem. So probably if you work with Bill, he showed you how you can measure the pressure. If the compressor getting a new pressure, that means it's not working at all. So probably you put your gauges on it, turn it on, and look for pressure. Some of the problems that you might run into, usually it's a pre-season startup, like now. Now, good luck getting a service call. Everybody's busy. I got 2 calls yesterday from companies looking for help. Interested in it? So, but again, they want you to be full-time. So if you want, I can give you a few phone numbers. People are always looking for people who know something, you know, go work as a helper. And actually the company that called yesterday, they pay $25 an hour, which is pretty good as a startup. So you can check it out. But
Should have dropped the school.
Everybody's like.
huh?
What company is that?
I forgot, I'll give you the name. But before you go on call, ask Bill,
So
because he knows all the people who work on here.
When they make service call protocol, what time of the day, I mean,
It could be any time. Of course, they always pay you more if you go
Yeah, like
during the night or midnight or something like that. So pre-season startup is going to be always a problem with the capacitor. The motor has been sitting for a while. It's rusted. It was not maintained. So you turn it on, nothing will happen. It's stuck. Sometimes the answer is as simple as just like give it a push or just like knock on it with a mallet. Knock out the rust and it will run. That can be a simple solution. Sometimes the motor completely seed or oxidized and you have more obstruction from the inside. Sometimes it will help take out the motor apart, clean up the rotor and put it back again. That could help sometimes. And sometimes you have to change the motor. So it's always going to be a pre-season issue, both for air conditioner and for oil. Preventive maintenance call. Every year when you go to the maintenance, some motors require you to put some oil. So you have to lubricate with a few drops every year. And sometimes you have to check also for temperature. If the motor is giving off a lot of heat, that means the motor is eventually going to go away. Something is wrong with it. So I had a service call one day on AC, and the technician came and told me, yeah, this motor is kind of loud and it's giving off a lot of heat. I think you should order a motor and keep it on standby. Let it run until it dies, but at least you'll have a spare part, because the order sometimes takes 3 weeks, so you have something on the side. So you might want to do that as well. Inoperative system calls. That's again, that's something to do with the CAD control, or sometimes those boards that give you an error and you don't know what's going on. So sometimes you have to go out and reset and check the wiring and see what went on with the error. With a lot of primary controls now. There's something like a computer reader, like the thing that you have in the car, where you go and plug it in and give you all the reports, and they all have meanings. Like, you go in your car, it will say, for example, what does it say? Ignition problem, misfire. Have you ever tried to read the check engine light in your car? You can buy, yeah, the code. You can buy a reader for like $30, a cheap one, and you can go online and find out, okay, so for example, Honda Aero E3, and so on, and you'll find something. So same thing you'll find with those controls. And again, with oil, if it's separated system, it's going to be simpler. Now they're getting more and more complicated. There's big boards with a lot of wires in it. I find it sometimes intimidating. But again, just take a breath and look at the paper and see what is going where. And sometimes it's easier just to change the board. The boards are not that expensive. You can change the board for like $60 and just plug in the wires where they're supposed to go. Okay, so this is chapter 9. Is it chapter 9 or 10?